Welcome to my channel. Let's try to solve another Leetcode problem today. Today we are going to solve number 29, divide two integers. And basically we are giving a dividend and a divisor. We need to divide them, but we need to return an integer. Yeah, if it is a minus 2.7, we will return minus 2. Yeah, for example, if it is a 3.3, we need to return 3. And the range is between minus 2 to the power of 31 to positive 2 to the power of 31 minus 1. It is a big number. Yeah, most of people don't like it because if we try to use a minus 1 by 1, we will get a time limit exceeded. We cannot solve it. We have to use another way. Here, I will use a accumulate way of accumulate the numbers to make it, to make the algorithm fast, to let it pass. Yeah. Now let me explain it in whiteboard first. After that, I will code it up in the code editor. Yeah. Now let me go to this problem. So the problem is asked to, I will give two numbers, 13 as dividend and 2 as divisor. If we are going to minus 1 by 1, as we know, 13 minus 2 to equal to 9 minus 2, it will be 6 steps. So if this number is too big, 2 to the power of 31, the divisor is 1, it will be 2 to the power of 31 times. Basically, it will be goes to 10 to the power of 8 or 9, but this will not pass for the design of the algorithm, for the design of the testing cases. We have to use another way to accumulate, to make it fast when we use the minus. We don't need to minus 2 by 2 each time. So for the first time, we minus 2. For the second time, we might want to minus 2 plus 2. For the third time, we would to minus 4 plus 4. So how would we design such kind of algorithm to make it fast? So I will explain it here. So the first tag is if A is more than and equal to B. For example, here is 13 and 2. So the 13 will be minus 2. We will get 11. After that, we have a counter to count. So this count, before it is a 0. After count 1, so here, because we've already minus 1, so this 2, we will define a variable as accumulator. So this accumulator will be bigger and bigger. Yeah, so the first step, it will minus only accumulator as 2, because the accumulator will equals to B from the beginning. So this is we count as 1 because it is only one number 2. So for the second step, this 2 will plus 2. Yeah, and here will be 11. So the 13 minus 2 will be 11. Yeah, and we also have another counter. So the 11 will be minus 2 plus 2 minus 4. So the result will be 7. And we need to check if 7 is less than 4 plus 4. So before 11 is more than 4 plus 4, it's all right. So here is 7 is less than 4 plus 4 equals to 8. So we cannot plus this 3. So currently, the result is only 1 plus 2 because result will be our function result is 1 plus 2. But up to now, we don't have to don't have to return all our function because our loop is still goes on because here a goes to 7 and b still equals to 2. We can still count. Yeah, so 7 is more than 2. We can count by 1, so it by 1. And then for the next step, 7 minus 2 equal to 5. 5 will minus 2 plus 2. Yeah, and 5 is more than 2 plus 2. Here we will count 2. Yeah, because 2 plus 2 is 2 times 2. Yeah, we need to count 2. And the result, 5 minus 4 is 1. And the next step is for this accumulator. It is 4 plus 4. It is 8. So 1 is less than 8. We will go to the outside of the loop. A is more than or equal than B. No, because A has already been 1. Is less than 2, we'll stop the whole loop. So this is basically what we get for our result. It is 6. You know, before it is 6 steps, but here it is 4 steps. But if this is a very large number, so our algorithm actually speeds up very fast because next will 4, 8, yeah, and 16, and 2 to the power of 31, you know. How many steps? Only 31 steps we've already got to the biggest number. But after that, we still have, for example, the first one may be 32 steps, the next one may be 16 steps, next one may be 8 steps. But in total, it is still log n time of time complexity. Yeah. Now let's code it up from the code editor. Yeah. In my explanation, I didn't explain the minus case, but we will use a negative Boolean variable to define this if it is a negative number. Yeah. So I will first use the absolute to make my calculation easier. So the A will be dividend and B will absolute divisor. And the result will start from 0 because we will return our result if the dividend is 0. So the result will still be 0. We don't need to go into the while loop. So the while loop will start from A less than B. Yeah, but before the while loop, we need also to define a variable negative. It will be Boolean. So inside it will be R. Yeah. So it will be the dividend more than 1 and divisor less than 0 and dividend less than 0 and divisor more than 0. So in this way we can make sure the negative it is true or false because we cannot use the multiplication, so we have to use the more than and less than operators to make sure it is a negative or not. So inside the while loop, I need a count. It will start from, let me check, it will start from 1. Yeah, it will start from 1, and I also need to define accumulate. So this accumulate will start from B. And the inner while loop will be if A less than and equal to the accumulate, our result can plus the count. Yeah, and this A will minus the accumulate. After that, the count should plus itself because we cannot use multiplication, and the accumulate needed to plus itself. So the accumulate. This is basically all our two loops. After that, we can get our result. But before we return the result, we need to have a check if it is a positive or negative result. Yeah. If it is not negative, we can return result. Else, minus result. Yeah. So we just after this, we need to return our result. But before return our result, we also need to have a check because the numbers will always between these two numbers inside. So we will use a min max or max min to return the result. So inside max, it should be minus 2 to the power of 31. And inside min, it should be 2 to the power of 31 minus 1. So this is basically all my code. Now let me run it to check if there's any error. Yeah, too many variables to unpack. Yeah, because here I need to use a result. It will start from 0. Yeah, it equals to 0. A more than B. Here another typo. Yeah, A should be always more than B. Otherwise, we don't need to calculate. Oh, here A should be more than and equal than the accumulator. Now, I think it's, yeah, I think I need to another run because I changed here. Otherwise, it will be a dead loop. Now let me submit it to check if it really works. Now you see it is around 48% of all submissions, and it is very fast, and the time complexity will be log n. Thank you. If you think this is helpful, please like and subscribe. I will upload more Leetcode problem like this. Thank you. Bye.